We'd like to welcome you to the AIA Westchester Hudson Valley Chapter webinar series. And we ask that you reach out to our sponsors who help support the chapter. And without further ado, I am going to introduce Chase, who is outside today as our speaker and managed to get it done. So Chase, we'll have you pull up your PowerPoint.
Okay, excellent. Looks like there's a couple of people in the waiting room here. I can let them in. All right, I will pull up my PowerPoint. I got to do screen share first, right? All right.
Correct.
Okay, got it. Good afternoon, everybody. My name is Chase Pierson. I am the Chief Operating Officer of Scan2Plan, and I am coming to you from an undisclosed location in Putnam County today, where I happen to be on a job site and couldn't get back to the office, but that's why I'm outside. So I'm looking forward to telling you all about Scan2BIM. So just a little bit about me and about Scan2Plan. So we have a Scan2BIM company based in the Hudson Valley, and we work with a lot of architects in the area, and we provide this kind of Scan2BIM service. So we thought this would be a good opportunity to explain how this stuff works. So without further ado, here we go. So as you probably saw from the email, these are the basic topics we're going to cover. We're going to go over, the basics of, what Scan2BIM is, how scanning works, how the software works, and how it integrates with your design platforms. So Scan2BIM is essentially the process of using Lidar or other data collection methods to create a three-dimensional representation of reality and use that to create architectural models. And Lidar is something that's been around for a while, but is in recent years become a lot more affordable. And so it's kind of been entering the market very quickly and is transforming workflows throughout the industry. So why Scan2BIM? There are a lot of reasons. So it's tends to be a lot faster than traditional site survey work. There is an extreme level of detail and accuracy in the data collection process and throughout the entire workflow. There is also, reference scan data and images that are byproduct of this process, which allow you to have, a view of the site wherever you are in great detail, and so you don't have to go back and forth to the site as much. It cuts down on site visits tremendously and gives you kind of confidence, peace of mind that you are dealing with the right measurements and dimensions. It's also something that's extremely useful for historical preservation projects. For instance, the Notre Dame Cathedral, when they had that fire, the reconstruction process is going to be based off of a Lidar scan of the cathedral that had happened just a couple years prior. So they've kind of got a millimeter accurate digital reproduction of the entire cathedral that they're going to use to guide the reconstruction. So data collection is all about generating a point cloud. And so what is a point cloud? A point cloud is a set of data points in 3D space. And it's basically, depending on the density of it, will look like a three-dimensional reproduction of whatever you were scanning. And they can be generated in a variety of different ways using a variety of different technologies, and that's what we're going to kind of get into here. But a point cloud's kind of the starting point for a scan to BIM process. These windows go away here. So there are a number of different options that are popular in the market right now. Structured light, which is essentially infrared. There's a scanner out there called the Matterport, which is popular, and it's been gaining usage. We have a number of them, and they are very great for creating a virtual tour and an approximate a point cloud that's kind of reference grade, but they're inexpensive and fairly fast. SLAM scanners are kind of new on the market, and they are they're scanners that you can walk around with, and you can scan a house in a matter of minutes, and they're pretty accurate. They're not super inexpensive, but they're an interesting technology. We'll go into a little more detail on that too. Terrestrial Lidar is the kind of the gold standard in terms of accuracy and reliability. They are a little expensive, but they from our experience, they are well worth it. And photogrammetry is the process of taking a lot of images and using kind of a computer algorithm to transform those images using math into a point cloud. And photogrammetry technology has been coming a long way over just the past few years, even the past year. The software options out there are coming along, but typically that's something that we use that regularly, but usually just for from a drone to do roof and site surveys. So speed versus quality. Terrestrial LiDAR, as I mentioned, is definitely the highest quality data you can collect. The terrestrial LiDAR scanner is mounted on a tripod, and if you get a really good scanner, it will have millimeter accuracy. Structured light has is pretty good in terms of cost and speed, but the data is not nearly as good as terrestrial LiDAR. SLAM scanners kind of fall in between. There's a big trade-off between precision and speed with the SLAM scanners, but they are incredibly fast, and we are just now starting to use them in our company, and we find that they're very good for large industrial sites. And I'll get into a little more of that a little further on. So this is the Matterport camera, which you may have seen. They're very popular. They were kind of built for the real estate industry. So a lot of real estate companies use these to create virtual tours of homes. This is kind of their signature thing here, which is called the dollhouse view, which is the scanner collects spatial data using infrared on interiors only. It doesn't, because it's infrared, it doesn't really work outdoors at all. And then what it does, they're kind of technology takes the imagery, it takes a bunch of 360 images inside the space, and then it maps the images over this three-dimensional mesh that's created by the infrared. And it does, it's kind of miraculous how quickly it does this, and how simple, easy to use it is. And it's a very good starting point for some projects to be able to get a basic layout and understand the space fairly inexpensively. But again, if precision counts, it's not the tool for you. So the Matterport cameras are under $5,000 to get fully set up easy to use, very easy to share. You can share a link to the to this virtual tour, via text. And, a lot of times we find that our clients like that because they can share it with other trades that are coming in for estimating, and it allows people to kind of really get a very detailed look at the site without being there. And it can kind of be used by anybody. They advertise about 99% accuracy, which, on a smaller scale thing, you might be off by a couple inches. On a larger scale thing, at 100 feet, 99% accurate is plus or minus a foot. So we've definitely advise people, caution people of them using that for mission critical operations. Part of the reason for that is that the reason it works so well and so quickly and inexpensively is they've developed an algorithm that automatically kind of registers the scan data. And because it's algorithmically based, the errors that it encounters are baked in. So the algorithm is limited, and it will always generate some errors. How big they are varies. And I think, let's see here if I can bring up this Matterport as an example, in case anyone hasn't seen it. So this is a giant urban castle up in Troy, New York that we worked on this year, and it used to be it was originally like an urban mansion, and it was a fraternity at RPI for a long time, and was just recently purchased by the fraternity brothers, and they're turning it into kind of a social club. So they they needed to get in there and kind of assess what was going on. The new owners are in different places all over the country or the world, and this was kind of a tool that they were able to use to kind of get their arms around what was going on here. And so we can share a link to this with you, so you can check it out on your own. SLAM scanners are handheld devices that you can just walk around with. So instead of putting a tripod and setting the scanner up to scan, which usually takes a couple minutes, up to 5 minutes per scan, sometimes longer depending on the brand of scanner you have, these you can just kind of click a button and start walking around. And it will collect this data remarkably fast. Yesterday, I did some testing with the Leica scanner, which is on the left here. It's called the BLK to go, and I was able to scan 60-something thousand square feet of industrial space within in a morning, and which is remarkable. However, there are some risks associated with that data, and it is a little bit tricky sometimes to get the data the way you want it. So, but there's a few popular brands out there. The Leica is very popular. The one in the middle is called GeoSlam. They're also have been growing in popularity. And on the right is a company called Naviz, which is also has a very good reputation as being kind of a cutting edge tech. They all have their pluses and minuses in terms of performance and costs. Naviz has some expensive platform fees to use, which some people find to be undesirable. So what are the good things and what are the bad things? The pros is it's speed. It's just fast. And it's fairly easy to use, but not quite as easy as it looks. The cons, less accurate. The point clouds are lower density and much lower quality, which we'll show you some examples of it. And there's much higher potential for point cloud registration errors. And registration is kind of putting the different scans together. So as I mentioned, the gold standard is kind of these terrestrial scanners. You know, at our company, we use the Leica Geosystem ones, which I think most people would agree would be the leaders in the industry. You know, the one on the left is called the BLK 360, and that's kind of you know, it's about 25,000 to get set up with that. The one on next to it is the RTC 360, which is closer to like 85, 90,000. We use both of those. The RTC is definitely the one we prefer. The BLK, but they're both, in terms of accuracy, they're both very good. The RTC is a little faster, and the data is a little bit cleaner. The Pharaohs are, you know, have a great reputation for accuracy, but they also have a reputation for being slow. So the BLK will spin typically about 2.5 to 3 minutes per scan. The Pharaohs can be like 7 or 8 minutes, which really slows you down. The RTC at medium density scans for about 90 seconds. The Trimbles are another kind of obviously a big company, and they have been more popular abroad, I think, and with you know, really large engineering firms, less so on the type of architectural projects that we're working on. So what's good about them is the precision. They are extremely accurate. And the data collected is also very easy to edit and correct. You're getting a bunch of individual scans, which you kind of piece together, and you can do lots of quality control, analysis, and validation on the data to make sure that what you're looking at is correct. And it's not really the case with any of the other solutions to the same degree. You know, the cons are, it's, you know, price, you know, the speed, it's not as fast as SLAM. And if you're doing a really big space, it's, you know, will take you days instead of hours. And, but there is quite a bit of a learning curve to get really good at it. And we've seen a lot of firms that have started down that road and abandoned it because it, you know, they didn't have the success early on, and it requires a commitment to really learning the technology. But once you do, it's wonderful and definitely the best. Photogrammetry is you know, doesn't need to be done by a drone. It can be done by you know, a DSLR camera or whatever. But drones get you up high, and so you can see. You know, there's parts of buildings that are sometimes very difficult to access, and a drone can get there quite easily. And so we are able to use photogrammetry to collect data from hard to reach places, rooftops, and large sites. We can scan a site and develop a very accurate, you know, topographic map, three-dimensional topographic map of a huge site in, you know, hours. So that's a very good kind of companion to some of the LiDAR stuff. It's not, photogrammetry really isn't used much in terms of interiors and structural stuff. It's more of a, right now it's mainly used as kind of an accessory to the terrestrial LiDAR. So data collection risks, and this is, you know, really important to understand. So the Matterport will always have errors, and we've seen a lot of companies that got really excited about Matterport, and you know, it can be very exciting, but it's also, you have to really understand the risks going into it. And a lot of it has to come down to just your experience level. You know, when you're low experience, your risk is going to be high. You're not going to know the mistakes you're making. When you have high experience, the risk goes way down. And it's true for all of these technologies. Best practices with data collection: when you're scanning, overlap is really the key to getting a good usable data set. So if you have just a little bit of overlap, you know, you might be able to piece these puzzle pieces together. If you have, you know, you know, 40 to 60% overlap, you're going to have a much easier time. And, you know, it's much more efficient to do a few extra scans in the field that will take you, you know, a few minutes each, than to not and get back to the studio and realize that you don't quite have enough data, and then you'll spend hours trying to you know, register the point clouds. So again, here's kind of a way to look at the comparison between the different scanners. So medium density is what we usually scan at. High density gives you you know, higher density, but it doesn't really help you on most things, because the medium density is so dense that it gives you more than enough data to do what you need to do. Low density, we typically find, is not advisable. The accuracy does go down at a distance. So when you have a scanner, there's a each scanner has a scan radius, right? So it can project light a certain distance. And when you're doing lower density, the accuracy has a fall off at a shorter radius. So medium density is what we commonly use, and what I would recommend. So here's some examples of scan density. And it's kind of hard to tell, but if you look at the, you know, the square and rectangle in the top left is a call out of the detail on this door. So when you look at the overall building, you're going to say, oh, wow, that looks, you know, pretty detailed. And this is low density, but when you look at the detail on the door, you can, you'll see as we compare to what a medium density looks like. So medium density, you can kind of start to see a lot more detail come in there. And this, you're going to get this PDF of this presentation, so you'll be able to look at it a little closer on a bigger screen. And then high density, you can really see it's, you know, it's pretty much looks photographic. So you know, one of the issues with high density, in addition to that it takes a longer time to scan, is that the files become much bigger and harder to deal with, and you have to have a much, you know, bigger computer to be able to work with them. So it becomes problematic if you try and do that. So the next part of this presentation goes into, like, once you get the data, what do you do with it? So if there's any questions on the first part about scanners and data collection, I'd be happy to take those questions now. Okay. So registration is the term used to describe taking these individual scans and putting them together into a larger comprehensive point cloud. So you can see on the right here, all these yellow triangles are scan locations. And the green lines connecting them represent the registration between them. So the integrity of the point cloud is measured algorithmically by the software, and uses a lot of math to help you validate the integrity of the comprehensive point cloud. So there's you know, there's a bunch of registration software out there, but I would say these are kind of the three most popular relevant solutions out there. So Leica Cyclone Register 360 has been around for a long time, and is definitely considered the you know, the industry leader. Autodesk Recap is a good tool. It's nowhere near as good as Leica. Recap was a acquisition by Autodesk a few years ago, and I think they started to compete with Leica, and they decided that that wasn't where they wanted to compete. So they've kind of deprecated they basically killed the team at Autodesk that manages that. They have a very small team now, and we use Recap. It's great for to view point clouds and to do some editing. If you're doing big projects, it's not the right tool to use. You can try, but it's definitely not the right way to go. But it is very useful for converting point clouds into the Autodesk proprietary point cloud formats. So that's what we use it for, mainly as a conversion tool. I'll go into what those formats are in a little bit. Cloud Compare is open source software, which is free to use, and it works on Mac and PC. The others are PC only. The Mac version of Cloud Compare does have some limitations compared to the PC version. There's fewer plugins that work, but it's a very, very powerful, very good point cloud viewing, editing, registration tool. It is not as user-friendly. There's, I don't know anyone that is using that as a replacement for Leica or even Recap, but there's some very, very powerful features in there if you want to take the time to figure them out. So this is kind of what a registration process looks like. This is a partially registered job. All the red circles represent scan points. Again, the green lines represent the connections between those two scan points. If it was a connection that was not quite as good, that would be yellow or red, depending on how severe the issue is. And the process is, it's kind of going in like a three-dimensional puzzle and putting all these pieces together. This is a kind of is 3D software, and so this is just kind of a bird's eye view of what this project looks like, and we call these things bundles. So you put a collection of registered scan points or setups is a bundle, and typically you will do bundles on different floors. It's a lot easier to create a bundle on a floor and then combine the floors as groups, bundles. So this is a single scan from the RTC 360, the Leica Terrestrial Scanner. So you can see kind of the scan radius and the detail that is there. The scan was where that black circle is. And so you can see there's, the dark spots are shadows where there's no scan data because the scanner is line of sight. So when you're scanning, you're going to go move the scanner to lots of angles so you can kind of remove any of those dark spots, and you'll have a complete data set. So that's what one looks like. And here's what it looks like, where kind of the placement, what you would do to kind of really get a full data set. So you're going to go around every side, the corner, and kind of make sure that you're capturing from every angle. So one thing that is important is that, if you're trying to get the roof and whatnot, you're going to have to elevate the scanner to get a good scan of the roof. So we use an elevator tripod, which can get us up about 20 feet, which is usually good for a lot of these projects. Sometimes we have projects we need to get a bucket truck in or something to get it even higher. But you want to have a good angle on all the subject that you're scanning from multiple points of view. So when you're doing the registration, you're fundamentally you're connecting two scans together at a time. So you're kind of marrying scan A and scan B. So this is the two different colors represent two different scans, and so this is an example of something that is not aligned, right? You can see where they're they're not matching up. So in the software, what you do is you kind of manually assist the computer and get it kind of where close enough that the computer can kind of help with the kind of the last mile of registration. And so it is very much a kind of a computer assisted process, and it does require skill and practice. And we all seem to enjoy doing it. It's very it's like doing a puzzle. It's like therapeutic. So here's the same thing, but actually registered correctly. Here's what a misaligned scan will look like from plan view, and there it's snapped into alignment. And here's what kind of the bundle will look like after we've kind of put it all together. And you can see kind of the detail on it. The detail, there's actually far more detail than you can even tell in this image. As you get closer, the detail is very, very fine. You'll see every grain of wood on the shingles. So, and that was again with the terrestrial Lidar scanner. That's with the RTC 360, which is, one of the better ones. So this is what scan data from a SLAM scanner looks like. So this is something I collected yesterday in Tech City in Kingston. So this was one single walk. So with the SLAM scanner, you can walk around and it will scan in real time and put it together. So each scan is called a walk, and you start in one point and you walk around and you end in the same exact point. And then it does its best to kind of put it all together. The quality of the data is not quite as good, but it is. I was very impressed with the scanner as I demoed it yesterday. But it's kind of remarkable. It's hard to see what this is, but this is probably, I don't know, 30,000 square feet. And it's just one big open room. So I was kind of able to do most of it in like one walk. So here you can see what the SLAM scanner data looks like. And it's a lot messier than terrestrial, right? So you can definitely see, you can see everything, but it's kind of like, it's definitely not as clean, not as sharp, not as crisp, and not as precise. But it is a lot faster. So point cloud formats, there's a number out there that you will likely encounter. A number of them are proprietary. So RCP and RCS are proprietary formats by Autodesk. And so if you're going to bring a point cloud into AutoCAD or Revit, you're going to need to bring in either an RCP or an RCS, and you can use a Recap again to convert a point cloud that may be delivered in another format to RCP, RCS, but that's those are the Autodesk formats. LGS is Leica Geosystems, so that is the format that Leica prefers or works with, and they have a lot of their plugins for AutoCAD and Revit and design software uses the LGS format, which has a lot of advantages. It's very lightweight. It's designed using kind of video game software, so the performance inside the design platforms is much better than an RCP or RCS, and there's some other advantages. E57 is a non-proprietary format, and it can kind of act as a replacement for any of the other ones above it: LGS, RCS, RCP. And it's very common, and oftentimes a format and a standard that is kind of a it's good. It's a good one if you're going to be sharing between teams that perhaps are using different platforms, but it's kind of a standard that's generally accepted. PTS and XYZ are also similar. They're kind of standard formats. They're not as popular anymore. They're kind of heavier. The file sizes are bigger, but you will see them. For instance, the Matterport. If you get a point cloud from a Matterport, it will be in the XYZ format, and that requires that you convert it to something else to get into most design platforms. So the other thing that is often a byproduct of point clouds is a mesh. So a mesh is kind of a bunch of polygons that are represent a lot less data than the entire point cloud, and the meshes they can be low quality, high quality, but they're an object. It's one single object that can be brought into. It's used a lot in visual effects. You can bring it into like Autodesk Maya or 3D Studio Max. There's some applications where you would use it in a architectural design platform as well, but it's not really kind of the main one that we use or most people use for the scan to BIM process. So modeling. Does anyone have any questions, by the way, at this stage? Okay. So modeling is what happens next. And that's a picture of Caitlin on our team in our office in Saugerties working on one of these projects. So when you're working in Revit, which is kind of the main platform, that's used for scan to BIM, even though AutoCAD, the full version of AutoCAD does work. Here's how you do it. So if you got a Revit project, you're going to go to the Insert tab, and the link panel, if it is, if there's a model built that already has a point cloud associated with it, you're going to relink it. Otherwise, you're just going to import it. But there's you'll have this PDF, so you can kind of use these instructions. But you're going to bring in these file types. It won't recognize if you have another file type in there, like an XYZ or something else. Autodesk won't see it, so it won't even pop up in this dialog. So you have to make sure that it's RCP or an RCS to get it into Autodesk. And the difference between an RCP and RCS is a RCP is a collection of individual scans, and RCS represents a single scan. So, oftentimes if you work with a scan to BIM company like us, like what you'll be delivered a Revit model, and you'll need to go in and link the point cloud that's also delivered. And once you do that, it all kind of snaps together where it should be. But this is how you do it. You go into manage links. And if anyone has any other questions beyond, after the fact, we're always happy to answer them for you. The other thing that you got to keep in mind is in the visibility and graphics tab, you want to make sure that that visibility is turned on to be able to see it. So in modeling, in Scan to BIM, the level of detail, or LOD, is kind of a common terminology used to describe different levels of detail or development. And it's what we found is that there seems to be a lot of the exact definition seems to vary a lot depending on who you talk to, but generally this is a good representation of what the LOD scale looks like. So on typical projects, we are working in LOD 300, which is here, or 350. There are some instances where we would go higher or lower, depending on the requirements of the project. Sometimes you just need kind of conceptual plans. You don't need as much detail. You're doing a massing study or just kind of trying to pitch a project. Obviously the the higher up on the LOD scale, the more time and money is to develop the model. So here's kind of a plan view of a Revit model that has the point cloud turned on. So you can see the point cloud data overlaid into the model, and it's really really interesting. I think really fun to see this, because you can really see where everything is, and you can really see if you know, you can tell the accuracy of your model looking like this. Here's another view that has a Revit model of a Firehouse that we modeled in Inman Square in Boston last year, and this has got the point cloud on it, so you can see the detail, and you can really kind of tell where, if you have deviation in the model from the actual data. You know, sometimes what will happen is, you know, in Revit, when you build a wall, it's perfectly straight, and sometimes in the real world, walls are not perfectly straight. So when you bring a point cloud in, you can oftentimes detect slight deviations that might not be visible to the naked eye, and we've had that happen a number of occasions where we were able to detect the slight lean in a wall that needed, you know, some structural attention that was unknown before. So here's a section view of gymnasium up in Troy that we worked on last year, and so you can really see, you know, how accurate the point cloud is, and why it's useful to use it in this process. There's another 3D view of this is the mental hospital up in Maine, I think we did last winter. And here's an interior view. This is a residential project in Woodstock. And you know, this is another barn that's in Woodstock that we worked on, and we were able to tell. You can see in the section view, the data is showing some serious sag, and it wasn't, you know, the sag wasn't quite as dramatic when you walked around. You might not notice it, but when we looked at it like this, we were like, wow. And we were able to tell, we could see where the sag was the worst, and it turns out some electrician had gone in and severed a footing or something, and it was which caused the sag. So the owner was interested to learn that. So a lot of our clients are not Revit users, you know, and wonder, you know, is Scan2BIM something that they can use if they're AutoCAD users? And the answer is yes. So the full version of AutoCAD does allow for point clouds to be used, just like almost the same way that you do in Revit. Very, very similar. AutoCAD LT does not. But what we do is we convert, we output DWGs from Revit into, so you can work with them in AutoCAD, but that's a process in and of itself. So we will look at that in a second. There's a fuel truck pulling up here. So converting BIM to CAD, you know, you may or may not know, is I'm gonna move over here. This guy to the left. So if you've ever had the experience of exporting DWGs from Revit and trying to deliver them to an architect who's working CAD, you probably know they are not very happy with what you gave them. And it's because Autodesk hasn't done a great job of, they haven't perfected that conversion process. and there's often far more detail in Revit than would be in the CAD, and so things just show up and they're not where they're supposed to be. The lines are not connected. You'll see trim where you don't want to see trim, and so it can be quite a process to transform those DWGs from Revit into a CAD product that's usable. And so that's something that we've decided to make part of our service, because it's really the only way that CAD firms are able to make this work for them. So this is, I guess this is kind of more of the same, but if you're working with a Scan2BIM vendor and you're a CAD shop, you want to make sure that they are converting it to your standards, because otherwise it's gonna be a lot of additional work on your end. So if you've got the full version of AutoCAD and you want to start working with point clouds, there is it's ready to go. There are plugins that can help you with that. Leica makes a bunch of plugins. There's a bunch of plugins from a number of different companies that that will work, that can kind of add value to that process. But you still get the same value of that quality control workflow to be able to look at the model relative to the data. So where is Scan2BIM used? So this might be kind of rudimentary, but I just wanted to touch on a lot of different types of projects. Historic preservation is something where Scan2BIM was utilized a lot in the past, and when it was a little pricier. Now that it's still used a lot for historic preservation, but it's kind of accessible on different price points in the market as well. Residential is something that's gotten a lot more popular recently. We have a lot of clients that are using Scan2BIM on residential jobs, which is allowing them to do a lot more jobs. It speeds them up tremendously. So that used to be not very common because it was cost prohibitive. Commercial projects, obviously, make sense. This is the New York State Bar Association up in Albany. We did this project last year, and it would have taken a very long time to kind of measure this building, and we were able to do it in 3 days. Institutional projects, it's really great for. This is a big public school up in Troy that we did for Mosaic Architects, and they had a lot of they have the one building there has a swimming pool in it, an indoor pool, and it had all this plumbing and pipes and tunnels and all kinds of stuff underground that no one really wanted to go crawl around in, and so we were able to scan that and give them very accurate drawings of everything that was there, and it saved them a lot of time. Mechanical, electrical, and plumbing is an area that is pretty fascinating. So the scan data is so detailed that we're able to, see really see everything, and we have gotten pretty good at modeling mechanical, electrical, plumbing fixtures. And we've done a lot of big jobs where this one is, I'm trying to see the light here, but I think this is SMRT Architects up in Schenectady, and it's kind of got an open thing. So we did all the duct work and everything that was up there. And those are very interesting projects, and usually people are pretty amazed at the level of detail we're able to deliver. Structural, obviously, there's a lot of value in terms of identifying structural components of a building, and oftentimes the scan data will give you insights to some structural components that might not be visible. They might be behind the scenes, but when you look at the point cloud, you can kind of make inferences and you can learn things, and kind of helps you in your detective work of finding out what's really going on structurally. Civil, this is a growing application. This was a project we did with the RPI School of Architecture up in Troy. We scanned this roadway and underpass, which is getting converted into kind of a community space, and so we were able to model, scan and model that whole area for them. We scanned it in less than a day. So, typical workflow on a scan to BIM project is it starts with scoping. You got to figure out what the requirements are, how much detail is needed, what, is it going to be CAD, is it going to be Revit, what are the important components and project requirements. And then, we typically, at our company anyway, we would assign a project manager and start the project planning, including the field work, how we're going to do that. And we do the field work, the registration, quality control on the registration work. Then we go into modeling, drafting, and then quality control review and delivery. So what's this going to cost? So this is often one of the first questions. So typically, the rates in the market for residential or small commercial, stuff that's under, 5,000-10,000 square feet, it's usually between $1 and $2 a square foot. That includes the scan, registration, and modeling. And in our case, delivery to conversion to CAD, if you're a CAD shop. As the buildings get bigger, the price comes down for a variety of different reasons. And then there's kind of, an important distinction is, architectural grade versus conceptual grade jobs. So depending on the level of detail that are required, you may opt for something that is more conceptual grade that will get you even kind of a lower cost per square foot. So for instance, we're doing a job in March. It's a very large public school, 325,000 square feet. They might tear it down, but they're required to have plans for it. So they were comfortable going with something kind of between architectural and conceptual grade, and it got the price per square foot down to something that was more suitable to their budget. So summarize, scan to BIM, it's about speed, accuracy, detail, having reference data that can be used throughout your design process, and risk mitigation, I think, is one of the big factors. So I can't tell you how many times, I'm sure you know, that where whoever measured the job missed something or made an error, and those can be very costly. So the ability to have that data with you throughout the process is a big factor in cutting down on those type of mistakes. And I guess that's it. So again, my name's Chase Pierson. Be happy to answer any questions, or my phone number's on there if you felt like calling at any point in the future. But thank you very much for your time, and I hope this was helpful.
Yes. Hey, Chase, I have a question.
Sure.
Thanks for the presentation. So one of the images you showed, it might have been Matterport. I don't know which, I don't remember, but it was, it showed a lot of locations around the building sort of at human level, but there were a couple shown higher. How did they get those points that were like in the air?
Like here? Is this what you're talking about?
Yeah. So those higher ones.
So those were captured on our, we have an elevator tripod. So it has 4-foot sections. So we add the sections to it and crank it up. and it can get up to about 20 feet. So we use that tool to get the scanner elevated so we can get a good perspective on the roof.
Great. And which technology was that?
It's basically just a tripod. It's a mechanical tripod that has it's kind of an expensive tripod, but it's it's just a a tripod that can go really high.
Okay.
It's using the same scanner. Same scanner that's on the lower scans is just being hauled up in the air.
Right, but this was of the 3 different options. This was the.
This was a terrestrial lidar.
Terrestrial.
So this was the RTC 360, the Leica scanner.
Okay. Great. Thanks.
Yep.
If anybody else has any questions, you can feel free to unmute yourself and go ahead and ask the question. Okay, we may be done with questions. We'd like to thank Chase for coming in today and surviving being outside with some outside distractions there. You did a fantastic job. We hope everybody has a great day. By now you should have or will be receiving shortly the attendance survey. If you have not received it, please check your spam file. And I also sent everybody the PowerPoint for the presentation already. So thank you all and have a great day.
Thanks, everybody. Thanks, Valerie.